Okay. Now today we are going to solve another problem. Okay. Look at here. Dry saturated steam at 10 bar is supplied to a prime mover. Prime mover look saturated steam with pressure 10 bar వెళ్తుందంట, and the exhaust pressure place at 0.2 bar. సో బయటకు వచ్చే ప్రెషర్ మనకి 0.2 ఉంది. ఇక డిటర్మైన్ ది ర్యాంకిన్ ఎఫిషియన్సీ రేషియో and specific steam expansion of the prime mover. If the indirected thermal efficiency is 20%. Also find the percentage change in the Rankine efficiency. అలాగే ర్యాంకిన్ సైకిల్లో పర్సంటేజ్ ఎలా చేంజ్ అయిందని కూడా కనుక్కోవాలి. ఓకే. ఇఫ్ ద స్టీమ్ ఈజ్ ఇనిషియల్లీ 90% dry. Okay. Now we are going to see how to solve this problem. First we are going to collect the given data. Solution. Now write down given. Here P1 P2 is equal to, take 10 bar, P3 P4 is equal to take 0.2 bar. Now thermal efficiency is equal to 20%, that is called 0.2. Okay. Now before going to solve this, we draw the diagram of temperature and entropy diagram. So now this is the graph. One, two, 2 to 3, 3 to 4. You know very well this is temperature and this is entropy. Yes. Now we go for here diagram of entropy and enthalpy. So now this is enthalpy, this is entropy. You know very well the Euler diagram of this. Two, three. Here is acting 0.2 bar. Now here is acting 0.10 bar, 10 bar. The saturation line is going like this. Now this is saturation line. Okay. Here we put this is H2. Now we take this is H1. Okay. Now we write down this is B and this is A. Okay. Sorry, here is H3. So now thermal efficiency. In the initial and final condition of steam, is shown in figure. Okay. Initial and final condition of steam. Okay, from Euler chart. Now here we know H2 is equal to 2775 kilojoule per kg and H3 is equal to 2150 kilojoule per kg. We take this value from Euler chart. Okay. Now we go for steam tables. from steam tables here, from steam tables, pressure at point 2 bar. Okay, we collect here HSI is equal to, we can write the symbol is double S also. Okay, kilojoules per kg. Now we know that Rankine efficiency, we know Rankine efficiency is equal to H2 minus H3 divided by H2 minus H6. Now substitute here the values. H3 is equal to divided by 2775 minus HSI is equal to, okay. Now to calculate this, we'll get 0.247 or 24.7% of Rankine cycle. This is the answer for Rankine cycle. Okay. Now we go for efficiency ratio. How to find efficiency ratio? Efficiency ratio. We know that efficiency ratio is equal to indicated thermal efficiency, indicated thermal efficiency divided by Rankine efficiency. Now substitute these values in here. We'll get here 81%. This is the find out of efficiency ratio. Now we go for here specific steam consumption, SSC. Okay, we know SSC is equal to 3600 divided by H2 minus H3. Now substitute here H2 value. Look at this, H2 is equal to 2775, H3 2150 minus 2150. Here calculate this, we'll get approximately 3.7 kg per kilowatt. Okay, now SSC we calculate here 3600 divided by H2 minus H3. The values here he can substitute. The answer will get approximately 3.7 kg per kilowatt hour. Okay, this is the problem to solve this. And now we going to here another problems for reheat and regenerative problems. Okay, now how to solve reheat and regenerative problems, okay, in Rankine cycle. Now the problem 1 is in here. Look at this problem. An ideal reheat cycle utilizes steam. An ideal reheat cycle utilizes steam as the working fluid. as working fluid. Steam at 100 bar 400 degrees centigrades is expanded in the HP turbine. HP means high pressure turbine. High pressure turbine to 15 bar. Okay. After this, it is reheated to 350 degrees Celsius at 15 bar. ఇక్కడ మనకు వచ్చేసరికి ఏంటంటే 100 బార్ ఇక్కడ 400 డిగ్రీ సెల్సియస్ దగ్గర మనకి స్టీమ్ అనేది హై ప్రెషర్ టర్బైన్ దగ్గర ఎక్స్పెండ్ అవుతుంది. ఓకే, ఇలా ఎక్స్పెండ్ అయిపోయిన హై ప్రెషర్ మనకు మళ్ళీ ఏమవుతుందంటే రీహీట్ చేసాం. ఎక్కడ 350 డిగ్రీ సెల్సియస్ రీహీట్ చేసాం 15 బార్ దగ్గర సేమ్ ప్రెషర్. ఓకే, now here and is then expanded in the low pressure turbine to the condenser pressure of 0.5 bar. ఇక్కడ కండెన్సర్ ప్రెషర్ వచ్చేసరికి ఏంటంటే మనకి 0.5 bar is given. Determine the thermal efficiency and steam rate. Okay, determine the thermal efficiency and steam rate. Okay, now we go for how to solve this problem. This problem we are going to solve wrong. Now we write down here given. The first we take here steam at 100 pressure. We go for here P1 is equal to 100 bar. Now here the 400 degrees Celsius we take here T1 is equal to 400 degrees Celsius is expanded in the HP turbine to 15 bar. Now P2 is equal to 15 bar. T2 is equal to 350 degrees Celsius. 350 degrees Celsius. ఓకే, ఎందుకంటే ప్రెషర్ 15 బార్ దగ్గర మళ్ళీ మనం టెంపరేచర్ అనేది ఇంక్రీజ్ చేసాం అంటే రీహీట్ చేసాం. ఓకే, అండ్ నవ్ అనదర్ డేటా ఈజ్ గివెన్ హియర్ దట్ ఈస్ కాల్డ్ P3.5 bar. This is the given data. Now we go for draw the TS and HS diagram for this. Temperature, entropy. Okay, now we're going to draw the diagram for this. Here it will come, I could put 1. This is now reheat 2 and temperature will increase. Okay, now again temperature will increase. This is the point of 3s. I can write down. This is 4. Now here I write down 5s. This is moving to 6. 1s. The object is moving. The steam is moving like this. Now in here, this is the diagram for TS, and now the pressure here is constant. Now the pressure is in here constant. The pressure is here also constant. This is the TS diagram. Now we go for enthalpy and entropy. HS diagram. In here HS diagram, look at First we go for 2 1. This is 1s to 2. Now the reheating 4. This is 3s, and now 5s 6. This is the process is going. Now here pressure is equal to 100 bar P1. Now this is the pressure is equal to 0.5 bar. Okay, so the process of adiabatic is here to going. Look at, you can draw like this. Okay, now we know very well here the pressure of 0.2 is equal to constant. Here also pressure constant, here also pressure constant. Okay, so these pressures all are in constant. Now we are going to solve this from steam tables. We collect the unknown data. From steam tables we are going to collect unknown data. At the pressure 100 bar, temperature 400 degrees Celsius. In here the volume is equal to 26408. Sorry, the units is here meter cube per kg. Now I want H, enthalpy at pressure 100 bar. Remember, this all values I taken from steam tables. Okay, I see the steam tables and write these values. Kilojoules per kg. Now we go for pressure 15 bar. Ts is equal to 192.28 degrees Celsius temperature in here. Okay, now we write down Vf is equal to 538 meter cube by kg. Hf is equal to 844.6 kilojoules per kg. Sf is equal to 144 kilojoules per kg Kelvin. Okay, at the same time now we go for G. Negative values here 13167 meter cube by kg. We go for HFG 184.5.3 kilojoules per kg. Now SFG 4.1262 kilojoules per kg Kelvin. And now take here Hg is equal to 2789.9 kilojoules per kg. Alage Sg is equal to 6.4406 kilojoules per kg Kelvin. And now go for another pressure is there. P is equal to 0.5 bar. The Ts is equal to 81.35 degrees Celsius. Now here we write down F is equal to, and now go for HF is equal to L, same alage SF is equal to we go for VG values for this. Now again HFG, SFG, similarly HG, అలాగే SG, okay. These all are the data we collected from steam tables, okay, to solve this problem. Now we go for how to solve this problem, okay. Here the H we take here, H2 is equal to kilojoules per kg. Now go for process 223S. 223S is isentropic, that is we write down S2 is equal to S3. This is the entropy, okay. So in here we go for here 223S. 223S, the process 223S. Here you can write down here S2 is equal to SF plus X3S into SFG. Now we know value of S2. Here you can take this, you can take S2, okay. So S2 is equal to 6.2182 kilojoules per kg Kelvin, okay. Okay, kg, kilojoules per kg Kelvin. Now S2 is equal to, you can substitute the value for this 2182, that is equal to SF here, where is in pressure 15 bar, okay. So 15 bar, why? Because this is pressure 2. Now pressure 2 here, SF is, you can take the value of here 2.314 plus, we need to find out dryness fraction, I don't know, so 3S. Now we take SFG, same 15 bar, P2 15 bar, SFG you can take this value in here 4.126, okay. Now calculate this, we find out 3S, X3S 0.946. So therefore H3S we need to find out here. The formula for is equation for into HFG. We know very well this equation. Now here we take here HF. This you can take this value for this. Now here we go for uh, HF 15 bar HF, take this value 844.6, 844.6. Now this is we find out. Now go for HFG. This is the HFG value 1845.3. Calculate this, will get kilojoules per kg. Now therefore expansion of steam in HP turbine, expansion of steam is equal to, here you can write down enthalpy He 2 to 3. Now we go for H2 minus H3s, H2 minus H3s. Here H2 we take this value in here 3099.9. Before starting I said here, look at this, H2 is equal to 3099.9 minus 2590.44. The answer it will come 509.46 kilojoules per kg. Okay, now we take from 15 bar. These all are the values. Okay, now we are going to increasing the temperature at 15 bar. We are going to increasing the temperature, that is called reheating. Now here I take the values here. V is equal to 18653 meter cube per kg. H is equal to 7 kilojoules per kg. S is equal to kilojoules per kg Kelvin. Okay, now here in expansion the steam in LP cylinder, so or turbine, low pressure turbine, you can consider a turbine. Okay, in low pressure turbine what happened, the enthalpy can write down here. Look at this picture, this is 4, you know very well, 4 to 5s, so we can write down H4 minus H5s. We can write down the equation here, H4 minus H5s. Since H4 is equal to 3148.7 kilojoules per kg, you can take this value. H value is H4. Unknown is only here H5s. So now we need to find out this. We have entropy S4 is equal to SF5. S5s. Now S4 is equal to S5s. You can write down here SF plus 5.SFG. Now we take S4 value for this. You can substitute here. Now SF, we go for SF at where is this, 15 bar. 15 bar. Okay, now now here you go for this is the point here, pressure. Look at this 5s. 5s is coming from this line. In this line our pressure is acting 0.5 bar. So in 0.5 bar pressure we take this values in here. SF is equal to, now we take this value. Look at here, this is the 5s to 6. Why? Because this is the 5s, entropy of 5s. Okay, now I can write down here SF is equal to 1.0912 plus, I don't know, x value. SFG also take from here 6.50305. 6.50305. Now solve this equation. We get here x5s, dryness fraction of 0.5. Okay, now we know therefore we need to find HF5s. HF plus x 5s into HFG. Now the value of HF is here 340.6. 340.6 plus, already we find, into HFG is equal to 2305. 2305.4. Calculate this, will get the answer approximately this. Okay, now expansion of steam in low pressure turbine. Now we're going to find low pressure turbine, expansion of steam here. Now expansion of steam in low pressure turbine, what happened? We'll see here. Look at H4 425. So 425 is low pressure turbine, 223 is a high pressure turbine. Now low pressure turbine we consider here H4 minus H5s. Write down here H4 already, you know, H4, this you can take H4. Okay, 3148.7 minus, already we found this value. Now calculate this, we'll get approximately, this is the answer. Okay, now here we consider H6 is equal to HF for pressure 3.5 bar, that is H6 is equal to 340.6 kilojoules per kg. Okay, look at here 6. Now here that HF, this HF is coming to take, that is HF is equal to H6. Okay, now we need to find here work done for pump. So WP is equal to H1s minus H6. The enthalpy of this here H1 minus H6. Here is pump. This is pump. These two are turbines. Now the pump is acting here 1 to 6. So here we can write down here 5 into P3 minus P1. Now the value of V F5. This is the value of V F5. Why? Because this is the fifth point. Look at here, 0.5 bar, that is the 5 to 6. We take this value for here VF, okay, 0.0010301 into 100 minus 0.5 into 10 to the power of 5. Solve this equation, we get here work done for pump is equal to kilojoules per kg. So now this is work done. So we go for heat supply. Heat supplied, you can write down here QS or QH, whatever can you take conveniently, you take this. Now here I can write down that heat supplied QS is equal to H2 minus H1S plus H4 minus H3S. Look at this enthalpy diagram. 1 to 2 is heat supplied. At the same time here 5 to 6, 4 to 3. Now here this is also heat supplied. These two, you can take these two values, okay, heat supplied. So now we go for here, substitute the values of all values. 350.85 plus 3148.7 minus 250.44. So now calculate this, we will get the answer of this kilojoules per kg. Okay, now here I take the values. H1S is equal to, now therefore H1 is 5 kilojoules per kg, therefore H1. So here the values, we know that values you can substitute here. This is the H2. Okay, before starting I said this is H2, I can substitute. Okay, now H1 we find out. Now here H4 is this is called H4, you know. Now H3 5 is find out, H5S also find out, and now H3 SCB here the value H3S. Okay, so all values I can substitute here and find the heat supplied. Now the thermal efficiency you can going to find, that is called by QH. So net work done is equal to, here two turbines is there, so work done of high pressure plus work done for low pressure minus work done for pump. We know very well this equation, since work done is net work done is equal to work done turbine minus work done pump. So now here I can write this, so QS, I can take this QS. Okay, heat supplied, you can write your convenience, no problem. Now substitute the all values we know here, and high pressure work done for low pressure, alage pump divided by heat supplied. Okay, now here we can find out, this is, look at this, in low pressure turbine this is the value I substitute in here. Now in here HP turbine This is the work done HP. This is work done LP. This is QS. Now calculate this. We find here 0.35, that is equal 35%. Okay. Now another point is there here, steam rate. The steam rate here SSC is equal to, we know very well this equation, by work net. Now substitute the values here. We get kilojoules per kg per kilowatt hour. This is the steam rate. Okay, so this is solution for this regenerative problems. Okay, in regenerative problems we can solve like this. Okay, mainly we go with this diagram, enthalpy and entropy. Once we draw this diagram, we complete all those things, and main important thing, we collect the data from steam tables. Okay, we go to see another problems for in regenerative in next class. Thank you.